How did running Postgres in Kubernetes go from no way to the way? You still remember the time you cannot run databases in Kubernetes. And what role did CloudNativePG and AsaDDB played in this transformation? So today, it's a pleasure for me to be here. My name is Gabriele Bartolini, and I'll be talking about the past, the present, and the future of Postgres in Kubernetes. As Monica was mentioning before, I've been using Postgres for 25 years. I'm a Postgres contributor. I'm also an ex-co-founder of Second Quadrant. Second Quadrant was a very successful service company around Postgres that was acquired by EDB in 2020, and now I'm VP Chief Architect of Kubernetes at EDB. I'm also a Data on Kubernetes ambassador, so I've been preaching about running Postgres in Kubernetes for 5.5 years right now. And I'm also a big fan of DevOps and lean methodologies. As I always say, DevOps is the reason that brought me to Kubernetes and the reason I'll be leaving Kubernetes someday for another adventure. I'm an open source contributor. Before CloudNativePG, people used to call me the Barman guy. Barman is a popular backup and recovery manager for Postgres. So I want to thank EDB for sponsoring this conference, and also for allowing us to work on both Postgres open source and CloudNativePG, and for donating CloudNativePG to the CNCF. So we are, I believe, right now the leaders in this space, the Postgres space in Kubernetes, thanks to our joint contributions to both Postgres, CloudNativePG, and also Kubernetes. So I'll be going, after a brief introduction, I would cover the past, the present, and the future, and then draw the conclusions at the end. So obviously, this is one slide about Postgres. I could talk for decades about Postgres, but there's really nothing to add. It's the most popular database in the world. There's this mantra, just use Postgres for everything, thanks to the extensions, okay? Anyway, if you want to talk more about Postgres, we are outside. We can talk later. We'll now take it as the most popular database and the standard de facto for relational databases and more, also in Kubernetes. It's important to state one thing. When we talk about Kubernetes and Postgres, our advice is not to use storage replication. Storage replication works for 99.5 workloads in Kubernetes. It doesn't work for Postgres because Postgres invented that more than 20 years ago. Okay, that's very stable. It's a robust technology, and it can also be controlled at transaction level. Okay, so you can have synchronous replication at transaction level, decide this transaction I want it also in another server. And it also allows us to implement shared nothing architectures, as we will see. If you do both replication in Postgres and at the storage, you have write amplification. So you end up writing the block multiple times. Also, it's important to say that this is not new. And also, as you can see, I'm part of the contributors of this feature introduced in 2009 in Postgres, which is called hot standby. And it's the capability to use use the replicas for read operations. Okay. There are other operators. I'm not talking about them because clearly, to me, now that CloudNativePG is in the CNCF sandbox, it's a community-driven operator. It's not owned by any company, and it's a vendor-neutral solution. And it's everyone's, as I always say. So you can contribute to that. Now our target is to become an incubating project in the next year and a half, and there are world-class adopters for CloudNativePG. So this means that As you know, this is the project maturity level for the CNCF. We are now in the sandbox. We are targeting incubation, and hopefully we will cross the chasm in the next 5-10 years. Okay. If you go to the CNCF landscape, you can find us. There's only 5 database projects, and CloudNativePG is the only one for Postgres. The past, I mean, we all know this guy. We love him, Kelsey. For many years, he's been saying that we shouldn't run databases in Kubernetes, and he was right. 5 years later, he changed his mind, but still people think, as first impressions last, that you shouldn't run databases in Kubernetes. That's false. I will never go back to VMs. I've been managing with my team here some of the largest databases in the world, and we all believe that there's no other better place than Kubernetes for running Postgres right now. Okay. And the decisions, the opinions of Kelsey, or in general, the opinions that you shouldn't run databases have brought to this typical deployment that we see. You run the applications inside Kubernetes, and you use a database outside Kubernetes in VMs or in a DBaaS solution like IDS, Google Cloud SQL, or similar. So going back to Postgres in containers, we need to say that we're not the first operator. There have been other operators. There's, the first one was Crunchy, the Crunchy operator. Then the Zalando one, which was the first one that I saw. I think it was Verona or Bologna when the Zalando team showed us what they were doing with their Postgres deployment at an Italian Postgres day. And that blew our mind. That was literally amazing to see how they were killing Postgres and it was coming up again in a different node. We didn't take Kubernetes seriously until April 2019 when Kubernetes introduced persistent volumes, local persistent volumes. And then we started our initiative at Second Quadrant. We first released Cloud Native Postgres as a proprietary solution. IBM Cloud Pak was a big pusher for the project. And then in 2022 May in Valencia, we open sourced CloudNativePG. And CloudNativePG has been growing. In terms of stars, it became 7 months ago, the most popular operator, surpassing Crunchy and Zalando as well. But as I said before, what really a game changer has been the introduction in the sandbox. So I've been reflecting a lot about having basically been using Postgres for 25 years. I started on-prem. It was bare metal. We would deploy a Postgres there. Then VMs came, and everyone was saying, you're a fool if you're going to run Postgres in a VM. Okay, nobody's going to run Postgres in VMs, just bare metal. And we all know that basically everyone is running Postgres in VMs now. Then, the infrastructure as a service came out, so people started to use infrastructure in the cloud to deploy VMs and then Postgres. But all these solutions were targeting day one operations, so primarily the deployment. Then DBaaS came out, so like IDS, Google Cloud SQL, and then what I call the cloud neutral Postgres era, which is based on CloudNativePG stack. So it's CloudNativePG, Kubernetes, and Postgres. And these are the only 2 solutions that I know of that target day 2 operations as well. So day 2 operations are maintenance as well. So if the primary goes down, automatically there's a failover and the system is up. So this is the present. So I was in Salt Lake for KubeCon, and we launched with the Data on Kubernetes community a report that said that database workloads are the #1 workload in Kubernetes. So, everyone talks about AI, but what is AI doing is actually accelerating, fueling the growth of databases adoption, because without data, you cannot run AI, okay? So this is the reality, From not running databases in Kubernetes, databases are now the #1 workload. So being cloud neutral means that you can actually leverage the infrastructure portability of Kubernetes. So with the same basically infrastructure, you can run it on private, public, multi-cloud, and hybrid scenarios. And also, especially in this moment, data sovereignty is really driving the need to retain full control of data. And what better than a stack that also removes vendor lock-in? So the cloud neutral approach with CloudNativePG is basically seen primarily in adoption of DBaaS solution in Kubernetes. So if you want to deploy Postgres, you can do it as an internal DBaaS. So you are an infrastructure team that deploys Postgres for the application developers in your organization, or external DBaaS that like you provide Postgres databases to your customers, and they don't know that there's actually Kubernetes underneath. It's also important because one of the problems that people have if they have large databases in DBaaS, I mean, apart from the vendor lock-in and the cost, is that they cannot port the data out of that solution very easily. Okay, so if we provide a way to move your data without downtime. But once you are in CloudNativePG in the cloud neutral PostgreSQL scenario, you can move your data using Postgres everywhere. You can use logical replication, streaming, whatever. Okay. Then the cloud neutral approach also preaches at least the analysis and planning of bare metal deployments with local storage and isolation of worker nodes for Postgres. This is what I call cattle versus pets, not elephants. So it's a little bit different. It's not like treating your database as a pet. It's more like a herd of elephants. So you need to treat the database a bit specially, but the specialty is just taints and tolerations to make sure that Postgres is isolated from the rest, physically isolated. Because logically, it could run in the same namespace of your application. If you want to read more about the cloud neutral approach, this is a blog article I wrote for the CNCF. So this morning, Xavier from Giant Swarm was talking about bare metal. I agree with what he said. I mean, if you can run Postgres on bare metal, you bypass a lot of ballast that you see on the left here. So you have a leaner solution and a more optimal usage of your resources. And for a database, even better performance if you can also access local storage, which I know can be counterintuitive, but it's a game changer. When we talk about CloudNativePG, there's 4 pillars that I always talk about. They are what McFadden and Carpenter in their book about cloud native databases called the Kubernetes native pillars. Okay, our operator, instead of using, for example, Patroni, which is a very common tool that exists outside Kubernetes, we implemented the logic of a cluster management for Postgres inside the operator. So the controller of CloudNativePG extends Kubernetes to understand what a Postgres primary standby architecture does. So we reuse pretty much Kubernetes for everything. Everything is declarative. From the ground, we are designed for observability with a Prometheus exporter, and we are secure by default. For us, if you deploy CloudNativePG as is, we have already, for example, removed super user access from the database. Okay, or everything is TLS. We create TLS certificates by default. Everything is encrypted. This slide is, I mean, if you want to take a picture or, once you have the slides, I won't go all these features, but it's production ready. Okay. So I invite you to try it if you haven't done it yet. There's actually one feature that I really like. It's the replica clusters, sorry, and distributed topologies, which is a very neat way to manage Postgres clusters across Kubernetes clusters. Our operator cannot manage, things outside a Kubernetes cluster, but we provide an API for you, for example, to demote a Postgres cluster and promote another one in another Kubernetes cluster, and this one will realign immediately. Okay, so it's cool. There's also a blog that I write. It contains several recipes. I'll provide the links at the end if you want. There's pretty much a use case for each functionality. CloudNativePG, I'll give you an example here, provides a CRD called cluster. This is an example of a cluster called Clapton that is made up of 3 instances, 1 primary and 2 standby. It sets synchronous replication, so we require that at least 1 instance is in synchronous replication, and we create 2 volumes, one for the PG data, which contains the blocks of Postgres, and one for the write-ahead log, a separate one. We could even use different storage classes, okay? This is what happens. So for example, you have your Kubernetes cluster, your availability zones, separate worker nodes. What the operator does, it first creates the PVCs. We manage PVCs directly. We don't use stateful sets, okay? Then once the PVCs are initialized, we start the primary. Then when it's ready, the read-write service is already pointing to the primary, so applications can connect there. And then we start creating the first replica and the second one. And we also have the read and read-only service. There's 2 more. So if there's a disaster, for example, there's a problem with the first worker node, Kubernetes immediately detects the problem and issues the failover, triggers the failover procedure. Failover procedure means that the read-write service, once that the primary is not ready anymore, doesn't point anymore to that primary. And the CloudNativePG operator promotes the most aligned replica. And when it becomes ready, the read-write service endpoint is updated. So at the end, the service doesn't change, so applications don't need to do anything. Okay, this is important. And when the other one comes back, it's realigned with it's demoted, so there's no split brain, and it's aligned with the new primary. So this is, as I was mentioning before, the most typical use case of CloudNativePG at the moment. It's what we call DBaaS approach. So this is the present. So most users of CloudNativePG use it this way. So you either use it in the same cluster of your database, of your application, but in a different namespace, or in an entirely different Kubernetes cluster. And this is the distributed topology I was mentioning before. You can even have a third region, okay, and do cascading. It's really up to you. What happens, we use the backup, the object store, to feed what we call designated primary in the other region, or if you want, you could also use streaming to reduce the lag. Okay, it's really up to you. You can use either or both. And this way, with this symmetric architecture, you have already backups in 2 clusters out of the box. Okay, so you're covered by this very simple solution, and symmetric architectures help us configure more complex like building blocks or more complex architectures. If you want to know more, there's another blog article I wrote for the CNCF about architecture for Postgres. So the future, in our vision, okay, DBaaS, internal or external, is good, but in our vision, and this is our DevOps mindset that brought us here since day one, this is what we wanted. This is what we wanted to do, what we wanted to achieve. We wanted to have the database part of the application development process. So this is what we call the microservice approach. And thanks to a capability of Postgres called transactional DDL, change management with Postgres is much easier than other databases. Okay, so essentially, the database should be owned by the application developers. Okay, this is what we see. This is our vision. So if you want to know more, again, this is another blog article that I wrote, and that explained the whole philosophy behind microservice databases. But the idea is very simple. We write software because we want to solve customer problems. Okay, there's customer need. We write a pipeline. Forget about the details of the pipeline right now, but we need to achieve customer satisfaction. Okay, we need a feedback loop from the customer to understand that if we did the right thing or not. So follow me now. So this is your local environment. You are the developer. You write the code for your app, and you also have your database. So you manage the schema of your database. You manage changes as well. So you can run tests locally using kind, whatever, Dagger, whatever solution you want. If they work, you push, you do the commit and push in GitHub, for example. You do a pull request. The pull request means that this is a DevOps capability. The orange ones are official DevOps capability. This is called version control. So you put everything in a version control system. You run automated pipelines. So you have test automation. You also shift left on security because you can check the vulnerability of your code and even containers, okay, when you build the container image. So once your test pass, you build the container image for your application, you can use that container image to run the same end-to-end test that you were running on your local machine in Kubernetes in your pipeline. So no variability. This is called continuous integration. And if, for example, you add a table, or you add a field to a column, or you change the values of a column in your database, that's a migration, and that can be atomic in Postgres. So you can do an atomic set of changes, and if one fails, everything is aborted. So you are 100% sure that either all changes are applied or none. So if you're the same principle, which is, as I said, database change management, if it works, basically what happens is you merge on trunk, on the main branch. So this is called trunk-based development. You have continuous delivery in place. Based on a release policy, which could be if tests pass, I release immediately, you can achieve, multiple releases a day automatically. So I have also continuous deployment. Okay. At the end, everything will run in the same Kubernetes cluster that you had set up on your machine. Okay, with no variability, and it's all automated. You can have, as I said, dozens of deployments a day. And all of these allows you to have feedback loops at an early stage on your laptop or in the end-to-end test. But most importantly, the customer can see immediately what you're doing. So in terms of a roadmap for CloudNativePG, our main goal is the incubation for the CNCF. We are also adding support for Postgres 18, adding a new way of managing extensions for Postgres in an immutable way, adding an isolation checker for the liveness probe of a primary. It means that if the primary is isolated, it shuts down. And other features. This is important. This is a feature that we have introduced in Postgres. Okay, it's important to understand that what we are trying now to do is to improve both Postgres and the cloud native environment at both CloudNativePG and Kubernetes. So, for example, Leonardo here is a Kubernetes storage developer. So we are kind of exploring territories that nobody has explored before. So we are even improving Postgres. This is a patch that was introduced for Postgres 18, extension control path. It also mentions CloudNativePG in the commit message of Postgres. And it's a very simple feature that allows us to use with image volumes in Kubernetes to mount immutable container images that contain an extension, for example, timescale, without having to put timescale or pgvector in the base image. Okay, so this will make extensible even the way you deploy Postgres. Okay. This is also important. We have just started the mentorship program with the Linux Foundation. So there's myself, Leonardo, Marco, and Armando Ruocco, who are mentors for the Linux Foundation. So it's the first time we do it. We have a new feature, and there's a new mentee, Ing. She's going to try and implement this feature here. So we're really excited. So you probably know the S-curve. Postgres was very popular on bare metal. Then VMs came out and became very, very popular. And now we believe that Kubernetes can start a new S-curve of popularity for Postgres. Again, cattle or pets, better herds. Remember these. I mean, treat Postgres a bit, differently from the other workloads. As I said, that means isolating Postgres nodes if you can, with taints, tolerations, and affinity rules. So this is the end, as the Doors used to say. Postgres is the most popular database, and I hope you understand how we were able to go from Kubernetes stateless to database are the number one workloads with CloudNativePG. And CloudNativePG is the most popular operator for Postgres. And we believe that the future will even be brighter, especially if you want to be part of this community. And as you said, as I showed before, we are now walking in unexplored territories. So we are pushing the boundaries and challenging the status quo also for people that work both in Kubernetes and Postgres. Okay, but we believe that it's not only doable, but it's actually the best way to run Postgres nowadays. Start, if you can, with the most typical use case, which is the internal or external dbus. You can migrate VMs to bare metal to reduce license costs, and you can also move away from dbus solutions with zero cutover thanks to logical replication. And when you are mature, you can also tackle the microservice database. So most importantly, the cloud neutrality opportunity for you, especially in this data sovereignty regulated world, this is a big opportunity. So one solution that can help you be flexible and grow with your organization. So I would like to thank some of the maintainers of CloudNativePG that are here, and Marco and Leonardo and Jonathan. So thank you. There's also Niccolo is another developer, and Jonathan Battiato is here who did the class yesterday. So thank you very much, and yeah, Monica.